Alright, hey guys, today we're going to talk a little bit more about similar figures. So we started talking about that in class today, but we're going to add to what we talked about in class. Okay, so you should be taking notes right on your note sheet. Okay, there's a bunch of blank space, so you can use any of that. If there's not room there, you can take it in your notebook. Okay, so again, add to your notes that we took in class today. Alright, so first thing that we talked about in class today was similar figures. Alright, so two figures are similar, and then here's the symbol. Remember, that means similar. Alright, so two figures are similar if, here's what we kind of figured out today, and this is in your notes. Okay, if the angles have the same measure, the corresponding angles, so that means if the angles that match up, so like angle A corresponds to angle D, those are going to have the same measure. Okay, so they're going to have the same angle measure. Okay, same thing with angle B and angle E. Alright, those are corresponding angles. They're going to have the same angle measure. So if I told you this angle was 30 degrees, angle B would be 30 degrees as well. Okay, another thing that is true about similar figures is that their corresponding side lengths are proportional. So that means if I take the corresponding side lengths, okay, and I put them as a ratio, they're going to be equal to each other. Okay, so again, I'll show you another example of that. Okay, so why don't we go ahead and do this example just as a quick review. So I'm going to give you two rectangles, okay? Alright, now I'm going to tell you that these rectangles are similar, but we're going to kind of test to show you how you can prove that. Now, if these are rectangles, first thing that we know is all the angles are 90 degrees. Okay, so these are all 90 degrees. So all the angles are equal. So all the corresponding angles are already equal. Okay, I'm going to put some side lengths on here. Okay, so I just put some side measurements. Now I'm going to add some side lengths to this picture. Okay, so I have some side lengths. Now I'm going to take the corresponding sides, so the sides that match up. So AD corresponds to EH. So I'm going to take that and write their side lengths as a ratio. So I'm going to put 20 over 5. Those are the sides that match up. Okay, now that should be equal, if these are similar figures, that should be equal to the ratio of the other sides that match up. So like DC to HG. Okay, so if I look at that, I'm going to put DC. I started with the big one, so I'm going to start with the big one again. Matches up with HG, which is 4. Okay, now I want to test, are these equal? Okay, so one way to test that, I'll show you one way to do it, is you just want to see, are these equivalent? Okay, do these equal each other? Well, I'm going to look, I can look going across or up and down. It looks like it's easier to kind of go up and down. So I think, well, how do I get from 20 to 5? Well, that's divided by 4. Okay, over here, if it's the same thing, it's equal. From 16 to 4, it's divided by 4. This other rectangle is like a fourth of the size. I shrunk it by a fourth, okay? So it's 4 times smaller, basically. Okay, so this is equivalent. These are equal to each other because they both were divided by 4. So now I know that these figures are similar. Okay, another way to think about that is if you just divide the ratios out. So if I take 20 divided by 5, I get 4. If I take 16 divided by 4, I get 4. Their ratios are equal. That's how you can test if they're similar. Okay, so let me give you another shape here. Let's look at this one. Okay, we want to test, are these similar? So I have two rectangles. I want to test to see, are these similar at all? Okay, so are these similar? So if we take a look, we have two rectangles. Let's find the corresponding sides. So in this one, we have 3 matches up with 3. Okay, so we have 3 over 3. And the other corresponding side, we have 5 corresponds to 3. Okay, now we want to see, are these equal? We want to test. If they are, then it's similar. Okay, so if we look at it, well, if I go from 3 to 3, it's just divided by 1. Over here, from 5 to 3, it is not divided by 1. Okay, so it's not the same ratio, so these are not similar. Okay, they do have the same angle measures. Okay, they do have the same angle measures here. Okay, but the side lengths are not proportional. Their side lengths aren't proportional. Okay, so these are not similar rectangles. Okay, let's check out another one. Okay, just as a quick little review. Okay, we want to test, are these similar? Okay, so I have two shapes. I want to test if they're similar. Okay, so if you take a look at it, first thing we should just look at, are their corresponding angles equal? Well, we have A here that matches up with E over here. Okay, same angle measure. Okay, B and F match up, D and H, C and G. Okay, so their angles are similar. Now we need to test their sides. Okay, we need to test all four of them. Okay, so let's start with, we have 5 matches up with 2.5. So I'll go ahead and write that out, 5 over 2.5. That's one of them. Let's look at these sides that match up. We have 6 matches up with 3. There's another one. Okay, let's take another one. We'll do the bottom slant. We have 7 matches up with 3.5. And if you notice, I'm always starting with the bigger one and then going to the smaller one. You could do vice versa. Okay, and then the last one, we have 4 matches up with 2. Okay, now I want to see if all of these are equal to each other, then these shapes are similar. So here's how I'm going to test it out. I'm just going to kind of see what these equal when I divide it out. Well, I know 4 divided by 2 is 2. I know 6 divided by 3 is 2. If I take 7 divided by 3.5 here, well, that's actually 2. And 5 divided by 2.5 is 2. So their ratios all equal 2. Okay, so these two shapes are similar because their corresponding sides are proportional. Okay, so they are proportional. They all equal 2. So basically, this big one is 2 times as big as the small one. Good. All right, now, one thing that we're going to be working on is trying to figure out, if I give you 2 shapes, we're going to try to figure out if the side lengths, or we're going to try to find a missing side length. Okay, so what that means, I'm going to draw kind of a little shape in here. So why don't you go ahead and draw 2 rectangles out. Okay, now we already know their sides are equal, so that's fine. Okay, I'm going to give you some side length. Okay, so I filled some side lengths in, so why don't you copy those down. Now, I'm going to tell you that these two figures are similar. Okay, they are similar. I'm already telling you that. So I want to know if I can figure out, well, how long is this missing side? That's what I'm going to try to figure out. Well, I'm going to use kind of what I know. I know in similar shapes that the side lengths are proportional. Okay, that they have to equal each other. So if I take a look at it, I have 15 in this one, matches up with 5 in this, the smaller one. Okay, I know that the other sides have to be equal to that. So I'm going to set up a proportion. Okay, I started with the big one here, so I need to start with the big one in this one. So I know over here that 18 matches up with X. Okay, so again, I did 15 matches up with 5, 18 matches up with X. These should be equal if they're similar. So now I just have to work on solving this. Okay, now there's a couple of different ways you can solve it. You can figure out, well, from 15 to 18, I like to think about, how did I get from 15 to 5? How did I get from 15 to 5 here? Well, it's divided by 3. This is 3 times smaller. Okay, so over here, if I do the same thing, 18 divided by 3, I get 6. So this missing side length is 6 in order for those to be similar. Okay, let's check out another one. Okay, if we look at this one, it says if these two shapes are similar, so I'm going to tell you they are similar. We want to figure out what's this missing side length, okay? So again, we know if shapes are similar that their side lengths, their corresponding side lengths are proportional. So let's take what we know. I know in this one, I know 2 corresponds to 1 in the smaller one, okay? Now that's the ratio of those 2 side lengths. Well, in similar figures, the ratios of the side lengths are equal. So I know that the other side length should be equal to that, the ratio. So I started with 2, so I need to start with the Z in this one. Matches up with 6. Oh, sorry, I did that wrong. So I said 2 matched up with 1. Okay, oh yeah. And then Z in this one matches up with 6. Okay, so now they should be equal. So I have to solve this so that they are equal. So I could do this a couple different ways. I like kind of thinking of it from 2 to 1. Okay, now, like I told you guys, I always kind of like pointing towards what I'm trying to find. I'm trying to find Z. So I'm going to do that here. So I think, how do I get from 1 to 2? Well, 2 times. Okay, from here then, from 6 to Z, I need to do times 2, which is 12. So Z should be 12. Now, let's think about that. Let's look at this and see if it makes sense. Okay, from this one to here, it's 2 times bigger. Same thing here, it's 2 times bigger. Okay, so these shapes are similar, and I just found that missing side. Okay, I'm going to give you guys one to try on your own. Actually, we're going to do this one together one more time. Okay, so I have 2 shapes. I'm going to tell you they're similar. Okay, so I want to figure out this missing side x. Okay, so first thing I'm going to do, I'm going to take the 2 shapes, they match up. I'm going to find their corresponding side lengths. So 16 in this one matches up with 12. So I'm going to write the ratio of their side lengths, 16 to 12. Okay, now in similar figures, corresponding side lengths should be proportional. So I'm going to take 24 matches up with x. These should be equal to each other if they're similar. So I need to figure out, well, what number, if I put here, makes these 2 equal? Okay, now there's a couple different ways to do this. Okay, this time I'm going to try going across. Let's see what happens and what that actually means. Okay, so from 16 to 24, I have to figure out, well, how many times bigger from 16 to 24? So 24 divided by 16 is actually 1.5. It's actually 1.5 times bigger. So over here, I'm going to do 12 times 1.5. And I get 18. Now let's see why that makes sense. So basically, here's what I did. When I went from 16 to 24 here, that's like from 16 to 24 here. That side's 1.5 times bigger. So that has to be true over here too. It's 1.5 times bigger. Okay, now I could have done it the other way. I could have still set it up like this, 16 to 12, 24 to x. Okay, I still could have done this, and I could have went this way, from 16 to 12. So I'm going to do 16 divided by 12. And that's 1.3. It's like 1 1/3 times smaller. So I'm going to do this divided by 1.3, repeating. So I would type in 24 divided by 1.33333, as many 3's as I could, and I get 18 still. Okay, so either way I did it, I got 18. This one, the numbers worked out a little bit nicer. All right, now I'm going to give you guys 2 to try. Okay, so these are the 2 problems that you need to come to class tomorrow. You have to have the work shown for these and the answers for these. That's going to be my check. So again, I want you to show me these 2 problems tomorrow. Okay, so here's the 2 problems. Make sure you show your work on both of these. You need to solve for the missing side, and again, both of these shapes are similar to each other. Okay, so you know they're similar, so use what you know to find the missing side. Okay, so again, those are similar shapes.